All right, in part B, we're going to look at what are p-values and how do you draw a conclusion using a significance test. The probability, assuming that the null hypothesis is true, that the statistic would take a value as extreme as or more extreme than the actually one observed, is specified by the alternative, is called the p-value. Now that's a lot of words, it's very wordy, it's hard to understand. But the p-value that we're looking for is this. What's the probability that we get a sample so far off from their claim, if their claim is really true, basically, if that helps at all. So we will look at p-values, interpreting them here, and also how do you use that p-value to draw an appropriate conclusion to your test. All right, so we're going back to the golf example. When Mike was testing a new 7-iron, the hypothesis was that the null is that sigma is equal to 15 yards, versus the alternative that sigma is less than 15 yards, where sigma is the true standard deviation of the distances Mike hits golf balls using the new 7-iron. So based on a sample of shots with the new 7-iron, the standard deviation was 13.9 yards. All right, so notice I used a different symbol here because it's the sample. I used the sample standard deviation symbol. Now, my sample indicates that it's less than 15, right? So there's two explanations for why is it less than 15. Well, either, number one, sigma is really supposed to be less than 15 yards. His claim is off. Or his claim is actually true, and we just got a sample standard deviation that was low by chance alone. Now, using that idea, B says a significance test using the sample data produced a p-value of 0.28. What does that mean in this context? Okay, here's what it means. It says if the true standard deviation really is 15 yards, then there's a 0.28 chance of getting a sample standard deviation less than or equal to 13 yards by chance alone. Now, notice some things here. This right here, the true standard deviation of 15 yards, that comes from my null hypothesis. This is the p-value that we will calculate. And then it's getting a sample right here. This comes from the sample that we got, okay? S of x equals 13.9. Now, why did I use less than? I use less than or equals to because it's a less than in my alternative, okay? It could be equal to this or less than. So as we practice this, you will see the pattern evolve on pieces that you will use over and over. All right, so what are two possible conclusions for a significance test? We've kind of modeled this, but I want to talk in theory for a moment. So it's easiest to think about this as about innocent until proven guilty in our court system. In the court system, there's two decisions that a jury can make. Either they find them guilty or they find them not guilty. Notice that we don't ever find someone innocent, okay? The claim is that this person is guilty. But my job as a defense attorney is to show that they're not guilty, that there's not enough evidence to prove them guilty. That doesn't mean they're innocent, but there's not enough evidence to prove them guilty beyond the shadow of a doubt. Okay, so in stats terms, if the p-value is small, we will reject the null. We will reject the guilty, and we would say, we don't have enough evidence to show them as guilty. Okay? So that we find convincing evidence that the alternative is true. That's what it means if our probability we calculate is small. Now what if it's large? If it's large, we fail to reject the null. We don't accept it, but we fail to reject it. Okay, that means we do not have convincing evidence that the alternative is true. I don't have enough evidence to show them not guilty, but it looks like they may be guilty. It's not a definitive they are. It's just I don't have enough evidence for the alternative hypothesis to be true. All right, so what are common errors that students make when they make their decision? All right, first of all, they don't answer in the context of the question. They just say reject the null or fail to reject the null. Well, they have to put context on it. Secondly, they say they accept the null. We never say accept the null. We only say we fail to reject the null. And thirdly, we don't link p-value to the conclusion. And I'm going to model this for you in some example here in a moment. But these are three key components to getting full credit when you make a decision based on a hypothesis test. All right, the significance level, alpha, determines what a small p-value really is. And this level is denoted as alpha. You see the Greek letter alpha, it looks like a little fish. And it is chosen by the test runner prior to this testing hypothesis, right? So they give you a significance level, and if your p-value is lower than that significance level, we reject the null. Sometimes you'll hear people say, if the p is low, reject the hoe. And that's one way to remember it, okay? Now, what if they don't tell you alpha? The most commonly accepted or used alpha value is 5% or 0.05. So if the question doesn't indicate a specific alpha level, this is what we default to, is 0.05. Now, if the p-value is smaller than the significance level, we reject the hoe, reject the null. We say that the results of the study are statistically significant. All right, so if we reject the null, then we consider it statistically significant. So you can't just throw these words around. You have to use them in the correct places. All right, so for his second semester project in AP Stats, Zion decided to investigate whether his students at his school preferred brand name chips to generic potato chips. After collecting his data, Zion performed a significance test where the null hypothesis was that p is equal to 50%, 0.5, versus that the alternative is that p is greater than 50%, where p is the true proportion of students at his school who prefer brand name chips. Okay, now stop for a second before we get to the question. Look at this. Notice the parameter. We use the p symbol, not p hat, and it's because it's a proportion, and we're talking about preference to chips. So he thinks they would prefer name brand to generic. So preference is greater than 50%. That's where the 0.5 came from. You could say preference, you could say majority, but that 50% is kind of the landmark. Notice also that we've defined the parameter. P is the true proportion of students at his school who preferred brand name or name brand chips. Now, it has to be in context, and you have to define the parameter. Now, here's the question at hand. The resulting p-value was 0.074 when he ran the test. What conclusion can you make at the end of the following significance level? So in part A, alpha is 0.1. My significance level is at 10% level, and I need to compare my p-value to that. Then I can make my decision. Do I reject the null or fail to reject the null? So here's how my answer would read. Because the p-value, 0.04, is less than 0.10 alpha, we reject the null. Okay, the second sentence is, there is convincing evidence that, now the context, that the students prefer brand name chips. All right, so notice I've taken the p-value, I've connected it to the alpha, and made a decision. My second sentence talks about the evidence. Do I have convincing evidence or not? And what is it evidence of? In this case, that students prefer the brand name chips. Okay, so part B, same thing, same p-value, and now I'm comparing it to an alpha or a significance level of 5% or 0.05. So my sentence first compares those two. Because p, 0.078, is greater than 0.05 alpha, we fail to reject the null. Okay, if it's greater than, we fail to reject it. There is not convincing evidence that students prefer brand name chips or name brand chips. So notice really, there's only two things that really changed here. Okay, well, three if you count the inequality. We're greater than here, therefore we fail to reject the null, and we do not have convincing evidence. Now, if you're getting confused, what do we have evidence of or against? It always refers to what is in the alternative hypothesis. Our alternative here said that the preference is greater than 50%. Okay, so that's what I'm describing here as for evidence of it. Okay, now you be careful because it doesn't necessarily mean that they like them equally. So don't ever add in a sentence saying, "Oh, this shows that they like them the same." No, it doesn't show that. It just doesn't show that we have enough evidence to say that they really do prefer them from this one sample. That's all it's saying. So then what should be considered when choosing a significance level? And honestly, you're not going to have to choose one. It's going to be given to you on a test or in a question. But what in the future, or if you're a researcher, what do you have to think about when you're choosing your significance level? There's two things. First of all, how plausible is the claim of the null hypothesis? The null hypothesis should be an assumption that people must be convinced is not correct with strong evidence, right? Something that they must be able to be convinced of if you have strong evidence. How plausible is it? And the second thing you want to check on is what happens if we did reject the null? If we reject the null in favor of the alternative, means expensive change in the distribution of a product or manufacturing, you want to make sure that your evidence is really strong to make that change beneficial. Because if it's a costly change and you do it unnecessarily, that's a lot of time and money wasted. So you have to think about those two things when a significance level is chosen.